Hello everyone. This is a short virtual course on how to get started with fog computing using the COSCO framework. This is the sixth and final video of the six-part course where we discuss how to run the custom scheduler we implemented in part 4 on a physical setup using COSCO. In the last video, we showed how to run the simple scheduler that we implemented in part 4 on a simulator. However, if you want to run it on a physical setup, that is also possible in the COSCO framework. So to do this, we can specify an environment variable in when running the main.py as an argument. And for this demo, we will be using the VLAN environment. However, we first need to deploy our physical setup. To do this, I'm using Microsoft Azure based deployment. To deploy our applications or deploy our physical model, COSCO allows integration with the Radon framework, which is a DevOps framework to deploy various framework elements. The service.yaml file actually calls an Ansible script that creates a resource group, creates the VMs, and opens the required ports and installs the new kernel that we require. And what we will do is that for this demo, we will only create 2 VMs. So let me open the WSL. Let me log in to my Azure account. As you can see here, I have logged into my account, and now let me run Opera deploy -i inputs.yaml service.yaml -c. Opera or Xopera is a DevOps service that allows us to deploy applications, deploy say framework elements like Microsoft Azure VMs automatically. So this will take a few seconds. So here you can see that the deployment completed successfully, and we have 2 hosts on Microsoft Azure, both with the B2S size. And if I go to the configuration, say for the VLAN type of the environment, I can add the IPS, I can add the number of CPUs, and I can also add the pre-implemented Azure power models. And as I have only 2 VMs in this system, I will have 2 servers in this server list. And what I can then do is that I will keep only 4 simulation steps or scheduling intervals in this experiment, with each interval being only 30 seconds. And for the purpose of this experiment, I will keep the defog benchmarks as an application. Again, the simple scheduler as my scheduler, and I will run the main.py with the environment VLAN and mode 2. This will start the InfluxDB service in the background. Try to delete the Docker instances that were running, but as this is a fresh installation, so there are no installations to delete. Then it will obtain the host information, the capacities like the RAM capacity, disk capacity, CPU capacity, and so on. This will take a few seconds. So for each of these hosts, we now have the RAM, the total disk, the total bandwidth, the RAM read, RAM write, and all other capacities. And just because now we need to actually execute the containers in say a physical node, so we actually wait for that particular time. And this has created the Pocket Sphinx application in the node with IP3. So this is VM1. It executed for 30 seconds. Then the second interval, it created an image ANSYS again at VM1, executing it again for 30 seconds. You can also see here the opcodes that it is calling in each scheduling interval. No new creation this time. So container stat actually gets the or monitors the resources of each container, the task, and host stat monitors the resources of the utilization metrics of the host. Created a YOLO application, but just because the number of containers is full, so we're not allocating it to anybody. As these are heavy applications, um, the wait queue is increasing, so we were not able to deploy ANSYS, the first instance of YOLO application, and the second instance. And this has completed. There were two migrations. No task was completed in this time, clearly because the number of simulation steps is very low. But still, we were able to generate the, say for example, host allocation for these two containers. Container 0 was only allocated to host 0. Container 1 was allocated to host, host 0 again. And the number of containers should be first 1 and then 2 for host 0, and no allocation for host 1, just to conserve energy. So yes, this demonstrates how the COSCO framework can be used to deploy um, a particular scheduler on a framework. And just because this scheduler intrinsically is using co-simulation in our model as we implemented, so this is calling the simulator under the hood to find out the best scheduling decision or the best target host specifically for each container. And this allows the COSCO framework or a particular scheduler that is being run on a physical environment to leverage simulation setups inside the COSCO framework to aid or facilitate decision making. Thank you for your kind attention. I hope this course helped you understand the basics of fog computing and gave you confidence to start your own research in this area. Please feel free to send me an email in case of any queries. Cheers.